Okay, everyone, thanks for coming back. So this afternoon, we have a couple of different things that we're going to go through. The first is Agile methodology, then we're going to go through some web basics. Then after that, we're going to split into the two tracks, okay? So I'm going to try to give this lecture, although it's not really my lecture because it's another person's deck. Okay, let's see, let's hoping that works. Okay, great. So what is Agile? Can anyone tell me what Agile means? Agile definitely means something like fluid, right? Not stiff, right? So when you think about traditional software development, it follows a very traditional waterfall model, and we'll get back to that in a minute. But Agile is a new set of methodologies designed to make things a little faster, things a little closer to the requirements that a person actually needs, a customer needs. Okay, so this deck was originally given by Winston Teal, who is also an alumnus of NUS. He's been out of school for quite a number of years, and he's been doing quite a lot of different things. Previously, he was with Pivotal Labs, and I'll get to that in a couple minutes. And that's where his experience of Agile comes from. So from 2011 to 2013, he was in charge of some of Pivotal Labs' technological development. And here he practiced the idea of Agile software engineering, in particular the three things that you see up there: test-driven development, pair programming, and continuous integration. So you don't know what these mean yet, that's okay. All right, so we're going to go over those with you. Since then, he's been a part of NEO. NEO is another big company that's in this area that's been buying up other startups. So they became a part of NEO. And then more recently, he left and is in charge of his own company now, Jolly Good Code, which he has founded. Okay, so Agile comes from many different backgrounds, but one of the backgrounds it comes from is from Ruby. So when Ruby and Ruby on Rails were invented, these were technologies that tried to change the monolithic architecture of software engineering using the basic waterfall model. And part of that is embraced here in Singapore by the Singapore Ruby group. So do try to meet up with them if you're interested. And in particular, last year and this year, he's in charge of RedRuby. Okay, it's a conference that's geared to industry professionals, but they have student tickets as well. So who's here has heard of Ruby before? Attending liftoff? Anyone? Okay, there's a very well-known person in Ruby, the community called Mats. Have you heard of him? Mats is the inventor of the Ruby language. Okay, he's from Japan, obviously. And he's going to be in Singapore. He usually doesn't come here at all, okay, for the conference, the RedRuby conference. So the reason why Winston couldn't be here today to give you this lecture is he's very busy preparing for this event where RedRuby is, again, having some really, really interesting people come by. So I encourage you, if you have your laptop in front of you, go visit the URL. You will learn more about what this year's RedRuby conference is like. Okay. There's also a newsletter that he runs, similar to Tech in Asia, where a lot of other people read news about this. Okay, just a general word of advice: no matter what framework, what type of project that you are interested in, chances are there are a lot of other people in Singapore, your alumni, your seniors, who are also interested in similar projects. Okay. You can find these people on Facebook. You can find them on different types of meetup sites. Okay, they have these breakout sessions that are all over Singapore. Sometimes even in Block 71, which is owned by NUS. Okay, so I encourage you to meet up with them and share your thoughts about your Orbital project. So why do software projects fail? What do you think is the main reason that they fail? Terrible developers? Why does software fail? You know, we've all had our trials and tribulations with Microsoft, Windows, or Office, or any of the other products out there. Why does it fail? No idea? Come on. You're all, well, most of you here in the room are budding computer scientists, right? You're not developers per se. Sorry?
Poor documentation.
Poor documentation. No. Thank you. Good try, sir.
They don't address customer needs.
They don't address customer needs. Is that what you said, Ben?
Yes.
Yes, so Ben has heard this lecture before. He doesn't count. Anyone else? No, I'm kidding. Okay, that's right. It's because a requirements analysis is actually really, really hard to do, okay? People give specifications like you did this morning about what I want my gift-giving app or what I want my project to do. But they don't understand how difficult it is to achieve that goal, okay? So the planning and estimation part of developing a software is actually really, really difficult to do. Okay, so this is really fun, and we're gonna click to this, and I'm gonna show you this link because I think this is a really good indication of why software development fails. Everyone knows Quora, right? The question answering site, right? We have a lot of people in NUS on Quora, okay? But in any case, let's take a look at this particular post, okay? Why do software development task estimations are regularly off by a factor of 2 to 3? You know, those cost overruns you hear about, you know, software not being delivered or construction projects not being delivered. Why is it the case that software is so hard to understand? Okay, so this person answered. It's a pretty good answer. There's lots of upvotes. But basically what it's down to is that these big tasks that people give, all right, they need to be broken down to the smaller parts. But the small parts are actually easy to figure out how big they are, all right? But the problem is being able to break it down consistently into small parts, right? So that's easy to do, especially if it's an engineering task like construction work. We know how to do, we know how to build bridges, we know how to do all of those things. But when it comes time to develop software that's never been built before, then it becomes very tricky, okay? So let me tell you an example story from this person. This is a really nice one, okay? For example, if you tell me that all quotes in some, you know, bidding system for a government contract are supposed to expire in 10 days' time, I'll say, oh, that's pretty easy. I'm just going to write a task to pull up all of those things and then expire them. You know, this is a simple action to do, right? If I estimated a week's time to do this simple script, it might take, you know, a couple, an hour or two to write up, you'd think I'm crazy, okay? So what happens? If you're a traditional software designer, you would have gotten the requirements from the customer, you would have gone back and say, okay, I'm going to go write this software to do this job, okay? I'm going to code it, okay? And then find out, you know, some more details that I need clarification on. Exactly when do you expire them when you say 10 days time, right? Did they expire at midnight or the time that they were provided, you know, exactly 10 days, 24 hours times 10 days? How long do I expire them? Do I write a job to do it continuously? Do I have to worry about whether a page is being looked at and I have to refresh and say, oh, that thing has been expired or not, okay? Or do I do it on demand? That means when a user is checking the database, then I'm going to expire them, okay? So even something as simple as expiring something in 10 days can be pretty tricky to implement because of all the details that are involved, okay? Then this person goes on. Then I find out it's 10 business days, not normal days. What does that mean? Oh, now I have to know what a business day is because every company defines business days differently, okay? Oh, business days doesn't include holidays. What holidays? We're in Singapore, but you know, half of your customer base is in China. Different holidays. How are you going to handle that, right? What about leap years? They're not even the same time. It's not every 4 years. It's not every 4 years except for every 100 either. It's more complicated than that. Okay, so a simple, seemingly simple requirement like doing something in 10 days time turns out to be pretty difficult. Okay, then there's other things, right? So all of these things turn out to be 1 hour's work, now 2 weeks' work. All right, so really, really difficult. Okay, so he's made a cheat sheet of other things that are really hard to do. That I think when you look from a business perspective, if you look to talk to someone who has an idea about a startup, it could be yourself. Okay, you ask them, how long do you think it's going to implement? It's going to take a lot longer if it involves any of these things. Okay, calendaring, merging and syncing data, build something that interacts with another system outside. That's why all of those projects that we're saying that you could do a project, Gemini, Apollo 11, they're more difficult if you do them correctly. Okay. So that's why software development is often off by a lot, and that's because people have traditionally followed a waterfall model for software development. What does waterfall mean? It doesn't mean this, okay? It means that the documentation is one of the critical things that make things work in the traditional model, okay? So everyone knows that you have to document what code you write, right? How many of you actually document your code before and during you write it? Okay, so a couple of people. The gentleman who said that documentation is important. Yes, it is important, okay? But many of us don't write documentation right away, right? We do it as an afterthought, okay? That's not a good practice, but that's the reality of things, right? So we rely on the documentation when we go to a customer and we say, here's the documentation, this is what I generated on behalf of your requirements. I'm going to write software to conform just to this step, the one that you showed me, okay? So we have to do system design based on that documentation, right? When you do customer requirements analysis, you go to a user just like you did this morning. And what are your requirements? I'm going to write them up into some documentation, okay? Then I have to design the system to meet that documentation requirement. And then I'm going to take those requirements and spread them out over many milestones, okay? Activity-based management. How long is it going to take to do all of these different tasks? But you already start to see the problem here, right? It's because that we have done our user requirements in one step. We have to plan the entire project from beginning to end right at the beginning, okay? Without knowing all of those little tricky things that I talked to you about earlier, about the requirements of expiring a code in 10 days. There are a lot of intricacies. So what happens? The estimation is not correct, the commitment is not correct, and then everything else goes wrong. Customers are not happy with you, okay? So in particular, because the traditional waterfall model only gets the person who you're trying to deliver the software to involved at the very beginning, and only then, okay, we have a very big problem. There's a mismatch in what the user actually needs and what they report. So many times we end up as software developers building a Swiss Army knife, but then the customer says, oh, but I want this other function, and I want that other function, and I want this other function. And then it becomes like the Swiss Army knife. I don't think you can call it a knife anymore. I don't know what that is. Okay, Swiss Army palette, okay, on the right, because you just built all of these functions for the customer. The customer should be happy, but they're not, because it's not what they wanted, right? Okay, and because of all of this, we have an unrealistic timeline of what's going to happen, right? Based on what you told me at the beginning, I say, okay, this job to expire tasks in 10 days, it's only going to take an hour of time, okay? I'm sure you all have this problem too. You're like in your modules, you say, oh, this homework assignment, I'll finish it, you know, in 2 days time. 5 days later, still not finished, right? 2 days, 2 hours before the deadline, still not finished, right? Then you finally submit it to Ivy League a bit late, or just, you know, a matter of seconds before, okay? So the problem is with this type of project estimation, we are usually quite off. So this is the waterfall model. You've seen it before, right? Basically, we talk to the customer at the beginning. We get the requirements that they need, okay? We go back from the customers. We take our money that we've gotten to produce the software. We take it back to our engineering team. The engineers design it. Then they build it. You know, after the design process, after we think we know what we're building, we build it. Then we have this phase called UAT. What does that stand for? Unit testing. Good try. User acceptance test. Okay, that means we bring it back to the customer and we ask them whether this is what they wanted. How often does that happen? They say, yes, that's exactly what I wanted. No, never happens, right? And then fixing, okay? So all of this time is the time to ship the product, from requirements, design, build, UAT, and fix, right? This is how we want it to look, right? We always say, oh, you must be very good at documenting your requirements. The better you do at this stage, the less time you're going to need later on, right? Okay, that's certainly true, but this is still the wrong model, and I'll show you why. Okay, because of this, right? We've already talked about it, right? Basically, there's a big gap that happens starting here, right? When you show the product to the user, they say, no, that's not what I wanted. You mean you took me 4 months to build this product for me? It's completely wrong, right? It doesn't get all that I want. There are certain things that I didn't tell you about. Oh, I needed that, but other functions, okay? So the problem is, at the end of the time, you have a big misfit between what you actually wanted to do and what you actually did. So software is important. It serves business needs. And what we want to do is find a better way to achieve these 4 goals, right? Plan and estimate. We already know we're pretty bad at that. What type of features do we need? What type of resources do we need to put into it? How many people we need to put on it? The duration that it takes to do something, and its cost. Okay, that's where Agile comes into play. So if you go to agilemanifest.org, you'll see the original manifesto. It's really short. Okay, it just basically says this important thing over here in the middle, which I'm going to show you on the next slide. Okay, so in the traditional software model of development, the 4 things on the left are crucial. Okay, this defines what. On the right are crucial. Okay. Meaning that we want to make sure that we have good documentation of what should be delivered. Okay, we bind it into a contract so that we can be tough on both sides, right? The customer can say, well, you told me you're going to build this, you didn't build this, I'm not paying you, right? And on the software development side, I said, well, I built it exactly according to this specification, you have to pay me, okay? So that's why this contract negotiation and comprehensive documentation is crucial, okay, these 2 things. All right, but we already know that's a problem, because when we give very comprehensive documentation about the requirements of a project, things change over time, okay? Even in your own projects that you're going to be doing this summer, over 3 months, what you have in mind now will be very, very different from what you actually end up executing later, okay? And for this reason, we need a different methodology to design quickly or in an agile fashion, okay? So by the Agile Manifesto, what we mean is that we value certain things on the left more, okay? It's not that the certain things on the right are no good. They're still useful, but we want to put emphasis on things on the left. So by individuals and interactions, what we mean is that we need to interact with each other, okay? Between ourselves as a software engineer, between the product owner, between the customer who's eventually going to use it. So those of you who are going to build products for yourselves, great, you already have your customers, okay? But those of you who are going to build products for other people, all right, you have to work really hard to draw them into the loop. So that the other team earlier, he says they want to be able to teach their parents or their grandparents about how to use a mobile app. You actually have to interact with these people, your family members or your friends or your uncles or aunts, all the time in order to get feedback on this process. Okay? We value working software, which means that at every stage, we're going to have something working. Even though it's not the whole product yet, we're going to make sure that every turning point, we're going to have something delivered that we can use. Okay? And we're going to be very responsive to change. When customers change their mind, you do a test with your user. They say, I don't understand this part. Maybe you can make it clear. Then you have to go back to your planning and iterate and put something else that was going to satisfy that requirement. Okay, so if there's anything that I can say about Agile, I would say this. It is taking the waterfall model that is very linear, okay, which you saw earlier, and breaking it down into very small chunks, which you can finish in several days' time. So one very important thing about the benefits of Agile is that you get higher visibility. That means as a software engineer or as a customer, you are working more closely with each other. You have to not just develop in isolation. You must be working together with your partner or with stakeholders that are going to be using your application, using your product all the time. Okay? You can adapt faster to changes that the customer makes. Okay? And most importantly, I think, is the fact that you get reduction in the risk and uncertainty of planning. Okay? The more you practice Agile, the better you're going to get at estimating how long it takes to do a certain feature or product requirement. We'll come back to this at the very end. Okay? For engineering team, if you look at larger software development houses, which you might be able to intern in 1 or 2 years, see that people that place an emphasis on Agile, they're not developing in isolation. They always have to talk to other people, and they feel more empowered by that decision. Okay, some comparison. This is our waterfall model, right? And if we do Agile, it looks a little bit like this, okay? You can see some key differences between the two, all right? One is that we are not getting rid of design, okay? That's definitely there. We have to design, okay? But we're going to do it in conjunction with all of the other things that we're going to do, all right? That means as we design, we're going to estimate, we're going to build our software, and we're going to test it all at the same time. Okay, I'm going to do it continuously, several loops, and you can see the time to ship is shorter. That doesn't mean it takes less time. It just means that the working time between an iteration where you have a working software component, a working project, although maybe a subset of it is much smaller. Okay, so the idea for Orbital is that at every end of the evaluation session, okay, every month or so, you should have something that you're ready to show to your peers, okay, through the group evaluation. You should target that roughly 15 days from today. You're going to show something to your peer group. Another month from then, you're going to show something else. Another month from there, you're going to show something else. Okay, so when you see the Agile product to market fit, it's much smaller. Why? Because we are getting people involved at every stage. Okay, you must talk to your customers regularly. You must build your product regularly, not just do it in sequential stages. It must be all interleaved for us to get some benefit from this Agile methodology. Okay, now there are lots of Agile methodology implementations. You can go to Wikipedia. Okay, those of you who have a laptop, look up Agile. You see all of these nouns there. And I encourage you, before you go to your software engineering class, which for many of you will be next year, you learn about some of these techniques because you'll practice them there if you haven't already practiced them in Orbital. Okay, so Winston came from a team that implemented extreme programming, so I'll talk a little bit more about that. So in an Agile project, there are several different roles that people play. So I'm going to describe what they are. Okay. There are customers. These are the people, your focus group that is going to try out your product. There are the product owner. That means the project manager, the person who's dealing with creating that particular product. Okay. The product manager actually sits between the engineers and the product owner. Okay. And the engineers themselves, which are all of you who are going to build that software product, test it, debug it, etc., deploy it. Okay, so each of these people have a different role involved, so let me go over what they do. Okay, customers are, of course, they're the important people who use the system and service and provide some feedback on what's going on, right? Whether they understand how it works, whether the deliverable meets what their particular use case is, okay? This is really important because your product may be used by a whole bunch of different people. Say, for example, in NUS, they could be used by professors. They could be used by students in your first year like you. They could be used by alumni. They could be used by prospective students if you're just, for example, building a website that has some database functionality. Okay, so you want to consider all different types of customers as potential people who can give you feedback on your method. The product owner represents the stakeholder, represents customers and the subject matter experts. Okay, so he's basically a front to the customers. Okay, and importantly, he manages the product backlog. We're going to talk about that and using prioritizing user stories. Okay, the product manager is not so important here, so I'm going to skip and just say about a part about the project engineers. They're the ones who write the code. They estimate how much time it takes to implement a feature or finish a user story. Okay, and they are really pivotal to the success or failure of the project. So with that in mind, let's have a show of hands. Who do you think is the most important person in this diagram? Is it the customer, the product owner, the engineer, or the product manager? The product manager? Can I have a show of hands? Who thinks it's the customers? Customers. Not many people think they're important. Okay. Customers are not important. Nah, screw them. They just buy the product. Okay. Product owner. Who says the product owner is important? One hand really high. Yeah, there we go. Okay, the singleton out there. All right. Who says an engineer is important? Everyone else is not here. Come on, try that again. Let's go. Customers. Everyone has to raise their hand. Come on. I'm shouting my voice for you. Come on. Okay. Product owner. Engineers. You're still not here. Everyone is rooting for the project manager. Is it project manager? There's a reason that guy is small. It's not important. Okay. All right. So if you answered at all, congrats to you. All right. But the right answers are pretty much the product owner, and they serve the most critical role in an agile methodology. So let's talk about why. Because they're going to make or break this project. Okay. And as I'm talking to you, you may be wondering, why is agile applicable to me? Right? I'm only in a team of 2. It's not going to be so hard to communicate. I just turn to the person next to me. What is this guy talking about? I don't know. Right? All right. So we're going to talk about agile from 2 perspectives: the management practice and the engineering practice. Okay? The management practice is what the product owner does, right? They're in charge of figuring out how to get this entire thing finished. All right? So they're in charge of inception, iteration planning, release planning, and retrospectives. So in engineering, on the engineering side, we're responsible for daily stand-ups, pair programming, test-driven development, and continuous integration. So I'm going to go over these 2 parts in a little bit of detail. Okay, already you've seen this diagram. You know, basically that Agile is a reworked version of the waterfall model where we do all of these things in tandem. Okay, and basically what happens is because we have these short iterations here, okay, we can afford to do it more than once. Okay, and in fact, when I talk to my FYP or Europe students, I also tell them the same thing. Don't finish the project just one time over the year. Finish it several times during the year, okay? Every month or every 2 months, finish a version of your project. So that extends not only to software development, it extends to other modules that you might be doing. So a translation for us is that for each iteration, we're going to do this practice of designing, building, testing, and delivering. Okay, and then after a few iterations, we're going to check back whether we're doing the right process or not. We're going to take a retrospective and analyze whether there can be changes to our process. Okay, and if you're involved in a very large software development process where it may take years or months to develop, much longer than Orbital, then you have a release planning meeting where you decide which features make it into a release. So one iteration is very simple, right? It just has these three things in it. You have to plan it out, you have to build it, and you have to release it, right? You have to give it to the customer to take a look. Okay? So that means story generation, clarification, estimation, prioritization, the building part, which is done by the engineers, and the release that is going to the customer. So let's look at each of these stages really quickly. Inception is something that the product manager does, okay? If you remember the person in the middle of that diagram, okay? Basically, what their goal is to make sure that customers' requirements are fulfilled, okay? And how do they do this? They do this by taking input from the engineers, okay? Analyzing the business case on the outside and finding out what are the types of stories that need to be fulfilled and setting priorities for them. Okay, so we have these release planning meetings where we do this to create a plan for each iteration that we can do. So in Orbital, again, because we only have 3 iterations, probably you won't have to practice this, but I'm showing it to you anyways. Okay, so here's a really useful part of this, all right? When you have a iteration, you have to do this planning, right? And you have to do this prioritization. So what happens is that engineers take a user story, that means a feature that you want implemented, okay? I have a feature that I want implemented, all right? Then the engineers know how to do it. They're gonna say, okay, well, for that feature, you need me to build a screwdriver, it's gonna take me 1 week, okay? Or you want a knife, it's gonna cost you 2 days, okay? So they're gonna give estimations of how much time it takes to build a feature. You will all have to practice this as well, okay? Because you have to document this, your project's development to your peers, okay? So estimate how long it takes for you to build a certain feature. The engineer does that, okay? The product owner, on the other hand, does the prioritization, okay? They're the person who decides which feature is the most important to get done when, okay? So for example, if you look at the diagram on the left, okay? Let's say it's today, you're starting Orbital, you have no idea what's going on, but you say, okay, I'm gonna make these features, all of these features are a box, okay? Okay, and at the end of Orbital, we'll have our minimum viable product, MVP, okay? The one that you're gonna showcase to your peers, okay? At the end of Orbital, okay? So in between, we're gonna have all of these evaluation milestones, one iteration, one iteration, one iteration, okay? And what we want to do is figure out what things need to be done and when, okay? So for example, let's say that the product owner, okay, somebody on your team who's playing the role of understanding the customer, says that, okay, actually the blue box, okay, represents a really crucial feature, okay? It must be in the minimum viable product. Without this, we'll never sell our product to an investor or our user, okay? All right? Then what we do is in this release planning meeting is we play this idea, and the product owner says, no, you guys are really nice. You, as engineers, you told me how long it takes, but I have to move this box to somewhere else, something before. All right? Say that as a product owner, I know what the priorities of my customers are. I'm going to move something around and prioritize it. Okay? So there's 2 different roles, right? One is the product owner. They are responsible for product managing and prioritizing all of the features that are going to be built in software, okay? Whereas if you're wearing your development hat, okay, you're an engineer in the group, then your job is to estimate as accurately as possible how long it takes you to finish a project, a portion, right? So all of these boxes represent some unit of time, and I'm going to estimate according to those units to say how long it's going to take. So for example, in Orbital, it might be a week. A week's worth of time is one box. Okay? User stories are chosen first in this iteration by the customer in order of the most valuable to the customer first. Okay? So that's why the product owner does it, because the product owner is the interface to your customer. It's the person managing the expectations of the customer and is trying to set an idea of what needs to be done in your product. Okay, there are a lot of things that you can take into account as the product owner. Okay, and when you practice this in Orbital, you should get used to this. When you create your user stories, think about the business value or the value to the users that it takes to build something, the amount of effort or manpower required to do it, and the risk added or removed by creating this feature. If I need it as a prerequisite to something else, maybe it's good to put earlier so I can get it done. Okay, one practice in Agile is called the daily Scrum. Okay, something you may have heard of. Who here has heard of Scrum before? No? Scrum it's not a misspelling of scum, okay? It's not scumbag or something like that, okay? Scrum is a methodology that we use in Agile development, okay? It just basically means trying to keep, again, very close count of what's going on. So this is Pivotal Labs in 2013. So they have a really nice office, as you can see here, okay? And basically what happens is every morning, if you go to an Agile development house, they have this stand-up meeting, lasts only for 15 minutes, okay? Where everyone in the room has to tell you something about what they've done, okay? In 1 or 2 sentences, how is the project doing? Which feature as an engineer did you work on yesterday? What did you accomplish? What are you going to do today? And are there any difficulties or blockages that might stop you from progressing? Okay? So you can practice this, again, with yourself and your teammate. Even though it doesn't make a lot of sense to do it in a team of 2, do it because the more practice you get with this methodology, the better you will be qualified to do larger software development projects later. Okay? So in your project log and your README, you can tell us that we practice Scrum every day. I reported something, and I have a log of all the things that I did that I hope to accomplish. Okay, another hallmark of extreme programming is pair programming. You are all doing that now, hopefully. Okay, working with a pair, maybe on 1 laptop or 2. But basically the idea is that in pair programming, you work together as a team using just 1 computer, 1 mouse, 1 keyboard. Somebody is the driver, okay, meaning that they actually do all the typing, okay, and someone is the observer, checking their work, thinking about other things that the person writing the code right now doesn't have the time to think about. So there's a lot of benefits to pair programming. Of course, when you program by yourself, you're liable to slack. Okay, that's not the reason why we're using Slack, but anyways, okay, if you slack off, it's easy to do that, especially if you're not both in the same room. When you're both looking at the same keyboard, the same mouse, you have to stay focused. Okay, it helps you get knowledge exchange. If one person is the developer, another person is working on the user interface, you can interface and learn from each other, right? And there's collective ownership. Everyone who's working on the project in the pair benefits to know the code together. It's not that, oh, I don't know this function, it wasn't written by me. You have to ask this other person who's not here, okay? Everyone has co-ownership, okay? And people in generally are happy when they can collaborate, when they talk to each other like all of you are talking. That's good, because we want engineers to be happy. We don't want you to code in isolation. Another part of Agile is called TDD, okay? Test-driven development, okay? You'll hear a lot more about this when you go to 2103 next year about software engineering, how important it is to have tests for your software, okay? So what we mean by test-driven development is actually that we create the tests for the software first, okay? Before you even write the software itself, you write a test for the software. That sounds a bit strange, right? How can you test something that's not there? Right? Actually, what we're doing is we are making the idea of documentation, I'll make the documentation, and putting it into tests. Saying all of the user stories, all of the requirements that I'm asking you to build, I'm going to put it into a functional test. All right? And what I want later on is after I've done the tests, I'm going to write code to pass those tests. Okay? So I'm going to make sure all of my tests are there. They're basically documenting what I want the system to do. Then I write the system to pass those tests. Okay? So there are certain things that we do in testing, right? We have tests that don't pass. Those are called red tests. Tests that do pass, those are green, of course. And refactoring tests, meaning that this code passes, but it's not as elegant as I want it. I want to refactor it, change it into another model. Okay? There's a lot of benefits to this that I won't go over, but basically, I think I want to highlight this part. Okay? It is that it is maintainable and it is a form of live documentation. Instead of sitting down with your customer and asking for what's this requirement, what's this requirement, what's this requirement, we have, as a software developer, our own documentation in the form of tests. Okay? We write tests, we pass them, then we can say our software is working correctly. Why do we do that instead of documentation? Let me give you an example. All right? Later on, let's say I have a working product already. Okay? Then I spend a week adding a new feature. Okay? The new feature works fine in isolation. Okay? When I import it and I use it together, oh, my system breaks. Right? I wouldn't know that if I'm using documentation. Documentation is just a piece of paper, right? Just has information there. But there's no way to test whether your software meets that documentation or not. Okay? When you use test-driven development, that's a benefit that you have. When you try to integrate a new feature in, when it breaks, you know. Okay? Then you can fix the bugs. Okay? So that's why we say it's maintainable, because when you add new features in, those existing tests that you write on the first iteration, on the second iteration, they will serve you all the way until you finish your software release. Okay? That's why we write tests. Documentation won't do that for you. Who's going to test whether your documentation and your code match? Certainly not your customer, and probably not you. So this is what a continuous integration and testing looks like. Okay, that means every night, every couple of hours, all the software that's built in this product gets integrated, compiled, tested, integrated, and checked against the test. If all of them are passing, then you'll see, for example, a dot here that shows that it's passing. Okay, so this particular screenshot, all of the different products that they were working on in Pivotal Labs, all tested and passed. Okay, otherwise you would see one of these things show up in red. Okay, someone has to work on that. It didn't integrate well. Something got pushed into the release code, doesn't work. Okay, so this is why we favor testing over documentation. I hope that's all clear to you, because it has a lifelong benefit of the project. Okay, you'll hear more about this in software engineering. We talk about code coverage. How much of your code is covered by tests? So continuous integration and deployment, again, it's practiced by the engineering team. It often avoids diverging or fragmented development efforts where developers are not communicating with each other because they could be working on different things. Say your friend is responsible for one feature, you're responsible for another. You don't talk to each other while you're doing the development. Then later on you have to integrate it and it doesn't work. Okay? So for Agile, how does it really work? We're going to talk about high-level stories and estimation and prioritization, because this is, I think, the core of what is immediately applicable to all of you, okay, and your Orbital projects. So up to now, you've heard me talk about user stories or requirements. What are they? Right? How do I articulate a requirement? Even in the design thinking workshop, you actually think about requirements, right? What are the things that your friend or the person you're giving a gift to, or whatever your project is, what do they need? Okay? So a user story is actually really simple. It's meant to be so that we can fit it in a compact form, okay? It's one or more sentences in the everyday language or business language that captures what an end user needs as part of their role, okay, or job function. So here's what it looks like. It's really simple, right? It's basically three-part form, okay? As something, I want something so that something can happen, right? That's pretty generic. Let's make that more concrete, okay? And after that, on the back of that, I will have some acceptance criteria. What do I need to do to make the story happen? That is from the engineering team, okay? This one is from the customer, okay, or from the product manager, okay? As a Facebook user, I want to sign up with my Facebook account so I can use the service immediately. That's a user story. It's at that level of granularity, okay? Very, very small, very, very specific, and tagged, very importantly, to a specific user role, okay? So as a Facebook user, not as, let's say, an NUS user. So when the engineer sees this card, okay, this user story, they're going to flip on the back of it. And they're going to write down, what is the acceptance criteria? How am I going to fulfill this story? How am I going to implement it? Okay? They're going to say, okay, I need, in order to demonstrate that this requirement is fulfilled, when I go back to demo to the user, I need to be able to follow this set of instructions. If it all works correctly, that user story is satisfied. Okay? So how do we estimate stories, right? This is all about storytelling, actually, right? So there are some techniques. You can use analogy. We can get expert advice from someone who's done it before, like a mentor or an advisor. You can take a big story and start to try to chunk it up into smaller ones, okay? But these techniques aren't enough, all right? So one way to get better at storytelling is to start to calculate velocity. Okay, so velocity comes from the idea is that all of us are incredibly bad at estimation and planning, okay? I told you that earlier, right? The traditional software model, oh, it'll be done by Christmas. 5 years later, you know, whichever game you wanted to play that was a promise by the developer never appeared, okay? Not on Xbox, not on anything, still not there. Why? Because they had very bad planning, okay? So how do we get better at planning if we're so terrible at it? Well, we follow this idea from Agile, okay? So there's an equation up there. Story points divided by velocity equals duration, okay? So actually what I want to estimate is your velocity, okay? But we're going to use this first, okay? So the first important point about finding your velocity, finding the story size, is to understand that time is relative. Relative in the sense of something like this, okay? In Singapore, we have small Coke cups that you can buy from Cheers or 7-Eleven. Okay, they look like the one on the left. Okay, if you go to the USA, what's their small size? Can you guess? Is it this one? This one? This one? Or this one? What's their small size? The second one. I heard the second one. Okay, that's actually not their small size. This is their small size. Yeah. This is just small, medium, large, extra large. That's in Singapore standards, but I think small starts here. We have medium, extra large, and double extra large. Okay? You can get 2 liters of soda in a cup in the US. Okay, no problem. Okay, yeah. So if you go to the US and you have a cup of Coke from your 7-Eleven, they come in very different sizes. What am I trying to tell you? It's not that Coke comes in different sizes in different countries, right? I'm just trying to tell you it doesn't matter what you're trying to estimate as long as you can estimate it relative to other things, okay? So we're going to use an imaginary time period called a story point, okay? One story point, okay? We're going to assign that to whatever task that you think is the smallest amount of time, okay? And everything else, we're just going to estimate according to that. So I think something is twice as difficult, 2 story points. 3 times as difficult, 3 story points. Okay? So when we do that, we can get an idea of how long it takes us to do a particular user story. Right? When I get a user story as an engineer, I have to assign the number of story points that I'm going to take to do this project. Okay? So I might take something that I think is a normal requirement. I'll say that's going to take 2 points of time to do. Something I think is simpler, 1 point of time. Another thing that I think is larger, 4 points of time. Notice here, these numbers do not have units attached to them. They don't have time attached to them. It's just a relative number. Okay? That's very important. Okay? So when we take our story points, right, during an iteration, I say, I'm going to implement this feature. It's going to take me 2 story points of time. 1 month later, I find out whether I did it or not. Okay? How long did it actually take me to do? That you know, right? Because in your project log, you will have written down, oh, this project, this thing took me 2 weeks to do. Okay? Then I have the duration. Okay? What is the purpose of that? Is to calculate this, your team's velocity. How many story points you can finish in duration. That's the measure of how fast you are as a developer in your own relative terms. Okay? You can't say that you're faster than another team because your velocity and story points are faster, because story points are relative, right? Doesn't make sense, okay? But it helps you estimate how long it's going to take you to get something done. Okay, so this is what we want to measure, okay? We're going to get better at measuring how long it takes your team to do things over 3 iterations. The first time, you may be wrong. Second time, you still may be wrong, but by the third time, you probably have refined your estimate of your estimates of productivity. Okay? You can derive it based on your own estimation, as well as all of this historical value you have by doing this many times. Okay? The more sprints you do, the more iterations you do, the better you will get at calculating how fast you do something. Okay? Of course, it depends on a lot of things, right? Number of team members and their skills. So I hope this helps you get an idea of what Agile Methodologies is about. In fact, if you're in a large team, you can do this using something called planning poker, something that you can look up on Wikipedia. Basically, the idea is that when you give a number of story points to something in a meeting, okay, in a large meeting, people tend to go with whatever the first person says. The first engineer out of 12 people says, I think it's going to take 5 story points. Then everyone's going to think, oh, okay, I guess it's going to be 5 story points then, right? So the point about doing this type of planning meeting is that we have all of the engineers on board give their estimates simultaneously, okay, in this game called planning poker, all right? And when we do that, we're able to get everyone's opinion and solicit why certain people have expectations that it'll take longer or shorter. So for example, the product owner, when he carries out this meeting, he may say, okay, Bill, you said it was 10 story points. Everyone else thought it was 5. Jane thought it was 2. Okay, Bill and Jane, can you explain why you thought it was 2 or you thought it was 10? Okay, then by thinking aloud with the entire team, everyone gets a better understanding of why things are the way they are for that particular engineer. Okay, so the key takeaway from this lesson, okay, is that in Agile, there are 2 roles, very pivotal, okay? The product owner represents the customers. Their job, whoever you assign to that, or maybe both of you are going to be responsible for that, is to be able to prioritize what things get done, okay? It's completely separate from what the engineers are doing, okay? If you put on your engineering hat, you are in charge of taking a story, okay? Remember, those stories are very short. They fit on a 3x5 card, for example, okay? And you estimate it. You tell us how long it's going to take in relative terms, in story points, Okay? And because you're always working with the product owner is always working with the customers, planning, design, and building are all interleaved. You get constant feedback, and hopefully you won't have such a big misfit in the product that you deliver. Okay, so that's all I have for you about Agile. Now, it's not going to be applicable right away to you. You may be thinking, right now I have not even started my project. I haven't done any storyboards. I don't even know what a user story is, for goodness sake. How can this benefit me? Okay, like a lot of other things that you're going to go through the next 2 days, this is a teaser. Okay, this is meant to seed your mind with the ideas that you need to practice, cultivate, and use during Orbital. Okay, once you get that, after a month or two, I think you'll see the benefit of this presentation. Okay, so with that, I'm going to end on Agile, and you'll have to give me a couple minutes while I fix things up, and we'll go over the web basics part of the lecture before splitting into tracks. Okay, so we'll be back at 3:40. Okay, 10 minutes from now. So you can take a break, go get some coffee, whatever you need, exercise, clean air, and then come back.